In major space news, scientists have found the strongest evidence yet of life on a massive distant planet called K218b, which is 120 light years from Earth.
So 1 light year is actually 5 trillion miles. So my mind can't even like wrap around how far K218b is, but the James Webb Telescope was actually able to study it and found that the planet's atmosphere suggests an abundance of a molecule that on Earth is produced by single living organisms like marine algae and bacteria.
The research was conducted by a team of scientists from Cambridge University, and the lead researcher said decades from now we may look back at this point in time and recognize it was when the living universe came into reach. If we confirm that there is life on K218b, it should basically confirm that life is very common in the galaxy.
And K218b is a type of planet known as a sub-Neptune, which is pretty common outside of our own solar system. So they're bigger than the Milky Way's rocky planets, but smaller than Neptune and the other gas-dominated planets.
And these planets are so mysterious, no one knows for sure what they're made of. Some scientists think the surface is covered with warm oceans of water, others think it's like molten rock, and others think there's no surface at all and it's just gas.
So after looking into all of this new research, we had to learn more about how scientists discovered the molecules, the different theories of what K218b is actually made of, and if we should be skeptical about life on other planets. So we spoke to Alexandra Doughton, who you probably know as Astro Alexandra. She has millions of followers and used to be a former communications specialist at NASA and Space Force.
Alexandra, just to set the scene, how big of a discovery is this?
This is a really hard question to answer because this could either be a huge, huge discovery pointing at aliens for the first time, or it could be reading data wrong. There are kind of three possibilities here. The first one is that this detection could be wrong. This is an exoplanet incredibly far away. It's 124 light years away, which is, trillions of miles. And reading chemical signatures in that atmosphere is a very difficult thing to do. Another option is that this molecule, this compound called DMS, could be created by something other than life. Now, this is very interesting because we don't see that on Earth. On Earth, this is only created by life. So if this planet has some sort of chemical process that we don't know about, I find that very, very interesting. And then, of course, the big one would be if detecting this compound is our first evidence of finding aliens for real. And that, of course, would be maybe the biggest discovery in humanity because it would change our meaning in the universe.
Can you just explain to us what these molecules that the scientists found are? We understand that on Earth, as you mentioned, they're found in living organisms. What are they?
So what was detected was either a compound called dimethyl sulfide, or DMS, or dimethyl disulfide. They're very similar. That's primarily produced on Earth by marine life, so algae and phytoplankton, and then it's released into the atmosphere. Actually, if you smell sea air, that's the smell of DMS. It has kind of a cabbage-like smell. It's also produced by bacteria. It's produced by fungus, truffles specifically. All of those things are life, and for that reason, this compound, DMS, has been considered a biosignature.
What other means could it be produced in outer space?
This is really hard. It could be produced without life, but we don't really know how. But we have actually detected DMS on a comet before, a comet I believe called 67P, and that was followed by a spacecraft from the European Space Agency that actually followed this comet and took a sample of this atmosphere that actually also detected DMS, and this comet seemed pretty lifeless. There definitely could be processes that create this compound, but we don't know what that is.
Right. So we read somewhere that scientists are performing these tests to produce DMS through non-living means. Do you know what those experiments are?
My best guess would be that they are creating simulations based on what they imagine the environments on exoplanets could be. So, they could do a really hot world, they could do a really cold world, a gas world, all of these kinds of things, an ocean world, and simulate what those conditions might be and what elements, what chemicals, what compounds might exist there and how those might interact with different environmental pressures.
So it's not like the scientists went out and was able to collect this like atmosphere gas. So how did they identify that these molecules are in this planet?
Yeah, so this is an incredibly cool process called spectroscopy. So the James Webb Space Telescope, which was used here, was looking at the star that this exoplanet was orbiting. And if you imagine looking at the star through a telescope, you can see the planet when it orbits and crosses in front of the star. And so when that happens, that planet is a shadow. What you can see is a sliver of its atmosphere. And then that's a unique barcode basically for the atmosphere of that exoplanet.
We like understand that that's like another debate kind of being had, like what is the makeup of this planet, and that's being debated. So can you tell us a little bit about like what the different theories are?
So it has a hydrogen atmosphere. The main theory right now is that this is an ocean world. So an exoplanet that's pretty much covered in ocean. Now, I think that we might be a little biased because we know that DMS comes from marine life on Earth. So I think we might, be jumping to conclusions here, but that's just me. What we see is that there's not a lot of ammonia in the atmosphere. And so a reason for that could be that the ocean absorbed it. But this can also happen with molten rock. Molten rock can also absorb it. So it could be a planet covered in molten rock, which is also really cool. Alternatively, this planet is more massive than Earth. There's this kind of vague class of exoplanets between the masses of Earth and Neptune that we don't know a whole lot about. And this planet kind of falls into that. And so it could lean towards Neptune. And it could be a gaseous planet, a gas giant, in which case it wouldn't actually have a surface at all.
So does Neptune not have a surface?
Does not have a surface.
Oh.
I never realized that. That's
Jupiter, Saturn, Neptune, and Uranus, none of them have a surface.
Whoa. Oh, it's good you started this whole conversation with a little bit of skepticism because we know that the level of confidence is only 99.7, but I guess in the science world that isn't concrete enough, 99.99999% to be able to say solidly.
It definitely makes the results less confident. And a lot of people also are kind of misreading that to mean there's a 99% chance that this is life, which is not what it is. It's a 99% chance that this chemical was detected, which is a huge, huge difference.
We're glad that you explained that because a lot of the headlines seem to kind of be conflating the two. You worked at NASA, you worked at Space Force. What is kind of the energy like within the scientific community? Is everyone kind of taking it with a grain of salt? Is everyone kind of seeing that this is a step towards this big scientific discovery, like you said?
I've seen a big shift. So at first, I think in general, people were cautiously excited, maybe doubtful, but there was some excitement there. I feel like there's been a big shift. And now I would say that overwhelmingly it's the scientific community trying to manage the spread of misinformation from these findings. So I think now it's kind of like a crisis management mode, but at the same time, they're really cool findings because of what it could be.
And so looking forward, we talked about how now scientists will try to replicate to see if there's any non-living ways to produce these molecules. Will it be checked by other scientists? Like what is next?
Absolutely. It has to be checked by other scientists. I think a lot of telescopes are going to turn towards this exoplanet. The James Webb Space Telescope is the most powerful telescope in space, but we also have other telescopes who are capable of looking at exoplanets when they cross in front of stars.
And I guess our last question, as a big space creator, you're obviously like plugged into everything that's going on that might not even make it into the headlines. What keeps you most excited about space exploration today?
I love things like this. I really love anything that gets people looking up space and interested in space and interested in astronomy. We as humanity have a lot of ambitious goals of, traveling to other planets and exploring them in that way. And that's very exciting. But I am always so blown away and impressed by our ability to find out ways to explore even farther from Earth and finding these new techniques and new telescopes and new ways of imaging things and being able to draw conclusions in that way because we can travel so much farther through space by doing that.